Dear Sigmafine users and partners, welcome to the Sigmafine Virtual Summit 2022. My role today is to introduce Sigmafine as a digital factory, transforming process and manufacturing data into digital assets. Today we have an audience composed by both existing long-term users and partners, and new professionals and companies approaching the Sigmafine technology for the first time. So the first part of this presentation will introduce the fundamental concepts defining what Sigmafine can do, and then we'll go through a set of real customer cases to illustrate the benefit generated by Sigmafine across different applications and industries. We'll also discuss the contribution Sigmafine can give to new business mandates becoming more common in the industries, like machine learning initiatives and circular economy projects. Finally, I provide a quick guide to today's contribution to the summit and the related key messages. A couple of years ago, Pinsoft introduced the concept, which then became the Sigmafine tagline, of transforming data into digital assets. Sigmafine is today defined as a digital asset factory which consumes different types of input data, including real-time data coming from the plant floor through real-time data infrastructure such as the PI system, transactional data from ERPs, oil movement system, terminal automation systems, and other types of data such as laboratory analysis, design, and planning data. Having to deal with such an amount of data, we first have to take into account that any source of information, being a flow meter, a lab analysis, or a bill of material, is affected by an error. Sigmafine transforms such an uncorrelated set of input data by validating data streams, reconciling network of measurements, conditioning results into a reliable and accurate dataset representing the most accurate one version of the truth suitable to sustain different company processes. But let's define the industrial digital asset factory in terms of its component. Unlike other types of advanced analytics, which are essentially data-driven, Sigmafine relies on first-principle model. The model is the representation of the set of process and business assets we are dealing with, and how they interconnect to each other. We can also define the model as the digital twin of the process or the network the user needs to represent. The business mandates sustaining a Sigmafine initiative determine how the model shall be configured for production accounting, nearly real-time monitoring, compliance, and so on. We'll see some examples of models in the next slides. Then, as information by definition is subject to inaccuracy, we'll assign a level of confidence to each piece of data we are going to process. A time rule is also to be applied. This defines the time frame of the analysis we are going to conduct. This typically spans from few minutes, in the case of nearly real-time monitoring, to classic daily accounting, to monthly periods for loss control program. Or it can even be by event or by batch around non-periodic time frames. Sigmafine is based on first principles. Therefore, depending on the case, input data are constrained based on the selected physical laws, so applying volume, energy, mass balances. In addition, on top of such balances, it is possible to apply tracking analysis to estimate physical properties like density or business properties like ownership at different points of our facility, as well as tracking composition of inventories and finished products across the production chain. Finally, a set of data quality metrics is defining how good the performance of the factory is. One of the most important missions Pinsoft undertook has been to promote a pervasive use of data quality metrics. It is not only important to produce a balanced dataset. This will be meaningless without the data quality matrix defining the level of its completeness and accuracy. So let us recall the main categories of data quality matrix Sigmafine produces every time you run a balance analysis. First, model-based metrics provide a model-wide indication of the level of redundancy, overall imbalance, tolerance, and corrections. Those indicators are typically used to track the ability of the model to fit the data and the model performance over time. Then we have an indicator related to points of measurement, which provide day-to-day indication of the meter performance, enabling meter biases identification, and supporting new meters' optimal placement for future investments. Finally, point of balance matrix provide quick indication of imbalances around nodes and process units, so to quickly address investigation on areas potentially affected by underlying data errors. Today, don't miss the speech by Sigmafine's partners, Emerson and Shuro International. They will present a story where Sigmafine data metrics have been used to identify the allocation meters to be investigated by a formal measurement audit. I would like to recall that SigmafineHub is the technology Pinsoft introduced to support digital transformation projects. SigmafineHub takes Sigmafine Server and Sigmafine Integration Framework capabilities and delivers them through a new web-based intelligent user interface. SigmafineHub was released in 2021 and has been already adopted by several customers. No need to migrate or redo any model, just plug SigmafineHub on top of your existing models and configurations. Don't miss today the Sigmafine roadmap presentation, which provides relevant insights about the future of SigmafineHub. Sigmafine has been applied to support digital transformation initiatives sponsored by a variety of different business mandates. Some of them are historically part of the domain being addressed by data reconciliation, like production accounting, energy balancing, utility balancing. To illustrate how Sigmafine can be applied, there is no better approach than going through some real cases spanning different users and industries. INEOS runs a very large petrochemical complex on the Rhine River in Germany. Originally, production data were aggregated only on a monthly basis, and there was no application of statistical balancing. So, in conjunction with a corporate project introducing a new SAP system, Sigmafine was selected to adopt mass balancing as the foundation of the accounting process. A model representing how materials flow through the different plants and representing all the inventories of the chemical complex was designed and configured in Sigmafine. Sigmafine was then integrated with a real-time infrastructure, in this case the PI system from Aviva, to collect process data, and the site information database to get receipt and shipment transactions. The accounting team became able to produce every day the site mass balance figures and feed SAP with accurate data, thus increasing the granularity of their insight. In addition, a specific workflow was configured to run a preliminary balance overnight to be then presented to the accountants in the early morning, and a lock mechanism configured to prevent accidental modification of an approved period of balances. Another production accounting case is from Petronas in Malaysia. Here, Sigmafine is bridging the gap among various departments. Sigmafine has been connected with the refinery information system to support the accounting department in both daily and months-end operations. The qualifying point of such experience is about integration. Sigmafine is not to be seen as an engineering workstation for personal use, but as a corporate application to be fully integrated in the company workflow. In such a way, Petronas was able to amplify the benefits coming from Sigmafine adoption and support the company under several aspects: planning and scheduling, finance, compliance, and optimization. Now, please let me introduce Marco Lanteri. Marco is Pinsoft's industry principal for refining and petrochemicals. He will give his contribution today by illustrating other interesting cases and introducing Sigmafine supporting machine learning initiatives.
ISAB, a refinery located in Sicily, is using Sigmafine for both the production accounting and the utility accounting, focusing only on the value-added utility networks. As we know, utility consumption is more and more relevant in terms of qualifying process efficiency and sustainability, not only in terms of fuel or electrical consumption, but also for what regards water, steam, air, and nitrogen. Last but not least, hydrogen is becoming the key vector in the energy transition. Sigmafine can be applied to such network and clearly identify and report productions, consumptions, import and export figures across the facility. Another use case we would like to share with the audience is the application of Sigmafine to provide both estimation of unknown inputs and KPIs computation around specific plants or energy-intensive equipment. The Sigmafine model represented in the picture on the left is an ethylene cracker, one of the biggest plants in the world with a capacity of 1.5 megatons per year. The detailed calculation of the mass and energy balance allows providing estimation of the heat recovery, heat losses, overall efficiency, and heat exchanger effectiveness. Other similar applications involve boilers, main turbines and compressors, and in general, the most energy-intensive equipment in the plant. Sometimes, by using Sigmafine for the daily mass balance, you can discover issues in the plant that could go undetected for a long time. This is the case brought by Secco, experiencing an abnormal drop in acrylonitrile output and high unit consumption after shutdown. A problem in the plant was found linked to the catalyst addition. After solving the issue, production levels were back to the usual range. This is a benefit that cannot be quantified a priori, but for sure increasing the value of a Sigmafine solution adopted by the customer. This is a case of inaccuracy impacting the profitability of the plant by inaccurate base sediment and water compensation of the crude tank inventory. Sigmafine detected the issue due to the redundant information provided by the flow meter to the CDU. Resolving this issue provided more reliable inventory figures to the planning and scheduling and prevented the interruption in product supply. Beyond the cases presented so far, we would like to introduce industrial trends where Sigmafine can play a significant role in both providing information not straightly available from process data and in making sure the dataset used to train an AI solution that make inference on the data is consistent with first principle laws. There are a number of AI machine learning projects implemented worldwide. The need of valid data is widely recognized. Here we are reporting just a couple of considerations coming from Gartner. If we consider more closely the process industry, higher data quality can be achieved mainly through two complementary approaches. Data-driven, which means implementing a data quality solution at the asset level, validating class of equipment, such as your fleet of valves, of pumps, etc. We will see an example of such approach in the time series presentation later in the day. And a model-driven approach, which looks globally at the network of measurement and provide indicators on the dataset. This is the approach brought by Sigmafine. Let's take as example a typical approach that considers applying a machine learning algorithm around a critical process such as a steam reformer. Process data will be fed to the machine learning layer, in particular operating conditions on the process side at the inlet and at the outlet of the reactor, combustion information, oxygen excess, speed of the fan, etc. Since there is more and more concern on emissions, the target of this machine learning project is finding the best operating conditions that, by maintaining the output in spec, keeps the CO2 as low as possible. The risk of a so direct integration is spreading errors and biases affecting the raw data directly to the machine learning, causing potential wrong or suboptimal findings. Bent gross errors affecting the machine learning layer, two data quality layers are set in the data chain. The data-driven quality layer works on the time series data to screen from problems affecting the measurements, such as out-of-range data, outliers, etc., building a set of data quality scorecards. Then, a Sigmafine model-driven data quality layer constrains the datasets to obey the conservation principles, in this specific case, a mass and energy balance. This methodology ensures a more robust machine learning solution as it both learns and looks in a physically meaningful variable workspace. The second application comes from life science projects which typically work on batches. The goal of the application is to find the optimal time to stop a batch production to minimize the related costs. Although apparently similar to the previous case, there are two main points to be noted. Sigmafine manages not only process data but also logistics data, whose integration with a machine learning layer could be less straightforward if done directly. Furthermore, Sigmafine, by using its tracking algorithm, produces and feeds to the machine learning a critical information, the batch cost, which is not directly available from the source data unless some severe simplification is made. So, to wrap up, always consider ensuring data quality layers are part of your solution when deciding to implement an AI or machine learning project to minimize the risk of failure or only partial achievements. And now, back to Massimo.
Thank you, Marco, for your intervention. Now let's see how Sigmafine can contribute to circular economy initiatives. Over the last years, circular economy became one of the global challenges and opportunities for process and manufacturing industries, with the objective of reducing and eliminating waste and pollution by recirculating products and material, so to support preservation and regeneration of the environment. Several foundations and associations have defined the framework for circular economy, and action plans have been already set by governments. Among them, a few years ago, the Ellen MacArthur Foundation issued a seminal white paper about applying mass balance principle to enable circular economy initiatives. Several companies, among them BASF, Eastman, Nestlé, have been adopting such approach to track and certify the amount of recycle-based raw materials contributing to the generation of the respective finished products. But let's define the problem. A so-called green production facility consumes both fossil fuel-based feedstocks and recycled raw materials, which cannot be differentiated from the point of view of the material properties. So what we want to track are not the physical properties of the material, but the origin, the source of them. When there is no segregation of recycled raw material across the production chain, there is the need to apply mass balance principle to understand and estimate how much of the recycled feedstocks can then be allocated to the finished products. The ability to run a proper mass balance protocol, together with the certification obtained through audits conducted by third-party entities, enable producers to report and certify the amount of recycled content allocated to finished products. This supports the achievement of the fundamental objective of circular economy and, moreover, increase the added value of the finished products given by the market. The contribution of Sigmafine to the circular economy mass balance protocol is based on the combination of a rigorous mass balance joined by the application of tracking analysis. By applying both rigorous data reconciliation-based mass balance and coupling it with material tracking analysis, Sigmafine can track the origin of the raw materials through the production chain, and therefore determine the composition at different points of the plant and the delivery of the finished products. I would like to close this section with a call to action for our community members. We invite those involved in circular economy initiatives to explore what Sigmafine can do to empower the circular economy mass balance protocol, moving beyond simple bookkeeping by adding a rigorous data reconciliation process, material tracking capabilities, all tracked by data quality metrics, and then an environment which fully audits each data transformation passage, both manual and automated. I would like to close the keynote with a quick guide to the upcoming presentations. Raffineria Heide will speak about composition tracking and the organizational workflow they put together to support the daily production accounting operations. Emerson and Shuru International will discuss how Sigmafine can support the measurement auditing process through data quality metrics. Aviva Contact will bring us instead into the mining industry, showing how Aviva products and Sigmafine provide an integrated platform supporting metallurgical accounting. Then, the Sigmafine roadmap will provide an update about the status of the Sigmafine server, as well as the new upcoming releases of SigmafineHub web components, including new features such as dashboarding, reporting, and a new authoring environment. Finally, two speeches from Trendseers and Omicron will discuss respectively the topics of integrated data quality and digital twin for the process industries. Thank you again for your attention and enjoy the rest of the Sigmafine Summit.